Greetings. One option that's available in most modern digital multimeters is the diode test function. Let's take a closer look at that. The two common characteristics listed are measurement range and source current. Source current is usually in the 1 milliamp range. At first glance, that seems to be an awful small amount of current to measure the voltage drop across the diode. Circuit to characterize forward current through the diode versus the forward voltage drop across the diode. Current limiting resistor, a variable resistor to control the current. There's the current meter and a voltage meter. Here's our test circuit on the breadboard. There's our 1N914 test diode, a meter in series to measure the current, a meter across the diode to measure the voltage drop across the diode, and a variable resistor, and a multimeter to set the resistance value. And there's our 1 milliamp of current and a 0.6 volt drop across the diode. The characteristics in these measurements are that the voltage and current are not proportional. So with the diode, a relatively large change in current produces a small change in voltage. So like here's the data sheet for the 1N914. With like 0.5 milliamps, you have a 575 millivolt drop. 10 milliamps, you have 725 millivolt drop. So, that ratio is like 20 times the current, about 30% increase in the forward voltage drop. Here's two digital multimeters with different diode range values. The Fluke 77 has a 2 volt range, and the Fluke 187 has a 3 volt range. And the higher voltage range can come in handy when checking diodes. So I'm going to check this blue LED with the Fluke 77. And it indicates open. If I check the same LED with the Fluke 187, 2.6 volts. In conclusion, the small amount of forward current through the diode gives a good representation of the forward voltage drop, and second, a larger voltage range can come in handy when checking for LEDs. So I hope you enjoyed this video, and I wish you the very best.